At this time, we will now hear testimony from Mr. Tony Nissen, the former OceanGate Director of Engineering. Mr. Nissen, thank you for being here today. Lieutenant Steele will administer your oath.
Please stand and raise your right hand. A false statement given to an agency of the United States is punishable by fine and/or imprisonment under 18 USC 1001. Knowing this, do you solemnly swear that the testimony you are about to give will be the truth, the whole truth, and nothing but the truth? So help you God.
I do.
Thank you. You may be seated.
Mr. Nissen, Lieutenant Commander Whalen will be the lead for your questioning. Lieutenant Commander Whalen.
Thank you, sir. Good morning, Mr. Nissen.
Morning, sir.
All of my questions are related to your background and then your experience with OceanGate as the Director of Engineering.
Sure, sounds good.
I'd like to thank you for being here, and I will ask you, as I am asking you questions, we will take breaks. If you need a break, please let us know. We'll let you take a break.
I may need a couple, thank you.
Okay. Mr. Nissen, I would first like to start off by having you tell me about your education and relevant work history prior to OceanGate.
Sure, sir, if I may, just take a minute, I just wanted to express my condolences to those lost directly. I know up to June of 2019, and there's some things that I saw in this presentation that are disturbing. I didn't think I'd need a break, but I wasn't kidding when I said I might need one later on. There's some things that bother me professionally and personally. So I apologize for some of my pauses. Education and background.
Yes, sir.
We'll start as it pertains to this function.
Yes, sir.
Solely, right? I mean, we all bring our histories to the table when we do stuff, but sometimes it's not appropriate. For this one, it actually started back in the 90s. I was an electronics tech in the Navy. I went in there wanting to be a firefighter, but that didn't work out. I went to dive school. I was a Navy deep sea diver and an electronics tech. So in those two functions, the electronics-wise, I could troubleshoot anything from a toaster to a radar set. Back then, even digital circuits. I'm old enough where I got tube theory. I don't know that they do that anymore. I left the Navy going into hyperbaric medicine. I was a HBO tech. I installed and ran the first multi-place hyperbaric facility in the state of Utah in the late 90s. Most of what we did there was wound healing and treatment, but it was a multi-place facility big enough to treat, I think it was a family of 6 or so. These are really large life support systems in hyperbaric environments. Definitely not to be confused with a hypobaric environment. I went to college after that, wanting to study electrical engineering. I was just good at electronics. Found that I love understanding how stuff breaks. So I studied material science and engineering, graduated from UC Berkeley with a bachelor's in that. For focus at college, I focused on carbon fiber structures, corrosion, electronic materials, and nautical science. Took a semester in shipbuilding. One of the most interesting classes I ever took. It turned out to help me a lot. After I got my degree with a background in electronics, I was hired by ATK Launch Systems. We built the solid rocket boosters for the space shuttle. I designed instruments for them. My claim to fame there is I designed an instrument to measure temperature, pressure, and displacement inside an O-ring groove during a rocket motor firing. A very difficult task to do. If everybody remembers the first space shuttle accident, that was an O-ring failure. And it turned out 20 years later, we were still troubleshooting possible blow-by by O-rings. In that job, I ascended to the level of project engineer. And so I was more or less the integration project engineer for the assembly of really, really large structures, rockets, more or less. I got a little bit more education in there. I have a certification in configuration management, CM2 principles from the Institute of Configuration Management. That's a semester-long course that we took in 2 weeks. Critical to maybe the discussion we're going to talk about today, for sure. I thought space vehicles was interesting. It wasn't my passion, trying to find something different. One thing led to another. I got picked up to build a test facility for BE Aerospace in Everett, Washington, and I did that. I built a test facility to test FAA and EASA conformed structures for static testing, meant to go inside aircraft. I built that structure for about $250,000, and we outperformed Boeing 23-11. I just wanted that on public record. After that, I went to certification. I ran projects installing certified systems in aircraft. Not my passion either. And then I found OceanGate. And I applied to OceanGate to be a technician. I just wanted to build submersibles. That was it. I actually didn't want to do the role. I didn't apply for the role that they asked me to do. That's probably my background in a nutshell for this.
You had mentioned certification. Can you talk to me about the importance of certification at your previous jobs?
Right, that's a good question. A certification provides a path for an outcome. It's a known path. It's a structured path. The outcome is not guaranteed, unfortunately. As we have certification in aircraft, every so often we still lose a plane. There are, in certification paths, there are allowances, maybe for convenience, that seem to not stop biting us in the rear. For example, in aviation certification, there is a term called similarity. And so when design engineers and project engineers and program managers are sitting at a table looking at a path forward, and they're trying to figure out how are we going to make this work, and you need to pick a certification path, the first one you want to do is similarity. And similarity says that, well, this design isn't different enough that we need a different part number or a different certification path. So even within certification itself, there's some ways that we get bitten by it, and it's out of convenience, and it's out of respect for cost, quite frankly. To go recertify an airplane, a passenger airplane, almost prohibitively expensive, which is why the path of similarity is loved so much. But the certification path itself does give a structured way to get someplace. Usually it's been vented. Usually it's been tested and found to be helpful. Does that answer that?
Yes. Thank you, sir.
Enough?
In what year did you begin working with OceanGate?
March of 2016.
Okay. And in March of 2016, what were you hired on as?
The Director of Engineering.
Okay. And what were your roles and responsibilities in that job as the Director of Engineering?
It's another interesting question. So I was pitched by OceanGate that the Cyclops 2 craft was nearly complete in the sense that all the items were in place. They just needed somebody to take it over the finish line. And they wanted somebody with an extensive marine background. I didn't talk about that in my quals. Taught sailing and yachting. I have a Coast Guard master's license, 50 ton. They wanted somebody that was, originally I was going to be the director of marine operations as well. They were having some issues in the marine side, and that's the execution side. So in their mind's eye, I was going to put together the parts and then just start executing it. And so I was, my apologies, that's my watch telling me I have an abnormally high heart rate. I was originally asked to just finish this. It was going to be a year, and that's it. I wasn't asked to design a sub.
Okay, and we'll get into that in a little bit further.
Sounds good.
When you joined OceanGate, was there a company mission or a vision, and how did that progress moving forward throughout your years?
Can you help me understand, like, a little bit about, like, what do you want to know about company?
Of course.
Vision.
So as you joined in 2016,
Yeah.
and you had mentioned the Cyclops 2 project, which we now know to be, or if you can confirm, that is the Titan project.
It was,
And
yeah.
so from here on out, if we could, we'll call it, understand that Cyclops 2 is Titan.
Sure.
Okay. So what was the vision for the site, for the Titan, and Mr. Rush's vision as you know it, for the Titan in the future of OceanGate?
Right. This might be hard to believe. When I hired on, I had no idea they planned on going to the Titanic. I was never told that.
At what point were you told that?
I was about, it was a couple weeks that I was working. I was talking to Joe Perry in his office, and he had a big bottle of the Titanic in there, and I thought, oh, that's a cool model. You must love ships, you must love wrecks. He didn't even come out and tell me specifically, but just the way that he was talking, I thought, oh, these guys plan on going on the Titanic. I had no idea. I know that sounds weird. Like, why would you take a job but you don't know what that vision is? But no, I wasn't told that's where we're going. I was told, hey, here's this carbon fiber idea in a submersible, and we want you to go finish it and put it together. Sure, I need something to do for a year.
In your preliminary interview, you stated that you were a good fit for OceanGate. If you remember, can you expound on that to exactly what you meant by that?
In order to fit a organization that, one, needs leadership and guidance. Two, is going to do something new and different, kind of outside the box. So you definitely have to be able to think outside the box. I am not a sustaining engineer. I'm glad we have them, but a sustaining engineer just keeps the design that's already there going. I would be bored to tears if I were to do that. So that doesn't fit my persona at all. I love the sea. It's not that I love everything about it, but I love working in the sea. I'm not a big fan of scuba diving unless I have tools in my pocket. I love doing stuff down there. I love the quiet and the serenity of it. I love ships. I love going to sea. And I love operations like that. I think they're fun. It gives me something in the morning to look forward to. I'm not much of a sit behind the computer, although I have one here, kind of a person. And so you kind of need to be that type of person to do that. It's to be able to be a technical person and an operations person. That is a very unique body to do.
And I'd like to read a quote from your preliminary interview, which is what I'd like to speak more pointed to. And you stated, I think every regulatory agency, with the exception, it is the FDA, Nuclear Regulatory Agency, Regulatory Commission, EOSA, FAA, another regulatory body. I don't know, quite a few. So complying with regulatory requirements, I had pretty broad experience with that as well. So pretty much from OceanGate's perspective, I was probably a good fit.
Yes. So that is another maybe unique history is to know how these regulatory bodies work. They all work a little bit differently, really, but then to understand some things like what the difference is between should and shall. Believe it or not, that's a long discussion in engineering planning meetings and when you're trying to get a design through. Do we have to do it? Or is it a good idea? And that's beyond whether or not the team gets past the discussion of whether or not it's a good idea or not. But no, true. To be able to understand what a regulatory body means, maybe even how to communicate with them, which is a little bit different, is probably helpful, I think.
When you began with OceanGate, what was the size of the engineering department at OceanGate?
0. It was Stockton, really. Let's say 1, but he wasn't doing the engineering. So the OceanGate employee, I was number 1. OceanGate had agreements to use APL for control systems and mechanical systems. And then it was Brian Spencer for the hull. And they already had an engineering team identified to cast titanium domes if it went that way. Brian Spencer would have been the carbon fiber end domes if they would have gone that way. And so that team was already in place, and that was the engineering team that Stockton was using for a while until they got there.
Okay. And we'll get more into those as well.
Sure.
So how many total employees were at OceanGate at the time when you first came on? Approximate.
6, 7, 8, 9, probably 10, I'd say. Mostly operations, 1 marketing, COO, Stockton.
And how would you describe the workplace environment when you started with the company?
It was, the first week was great. It was hard to catch up to them. It was obvious that I was coming into what I felt was like a club, and that's kind of hard being an outsider. All these folks had worked so long, and so I was searching for how am I going to establish my legs here, and what am I going to do? So the first week was good. It was quite literally the second week where I started wondering like how am I going to be here? How am I going to exist? So it was a challenge from about week 2 on.
And were you able to overcome that challenge?
No, I don't think so. Not within the broader OceanGate whatsoever. But the engineering team that I built, absolutely. I think we ended up getting to about 25 people, I think, if I remember right. It was pretty substantial. We were 50% of the company, and I think I felt most at home there. But no, until I hired my first hire, maybe I didn't mention that in my calls. I'm not afraid to stand in the forest alone, and I was kind of like that a bit.
And you had stated that when you first were hired, you weren't aware of the Titanic expedition vision or moving forward.
No, yeah.
So what were you told regarding the Titan project at the beginning of your employment? Where did you come into that process at?
They were just going to build a deep sea carbon fiber hulled submersible, and I thought, that's interesting. Okay, like they have a couple of reports that said it's possible. All the items were in place. Really, it was an integration project. So, yeah, I could do that.
Was there any mention of having this submersible classed or built to a classification standard?
There was talk about, yes, so Stockton would go back and forth on whether or not he was going to have it classed, but the classing conversation was always there, and the inspection. And when I came on, it was going to be a much more collaborative effort with either regulatory or classing agencies. And I know throughout the weeks, I think Stockton tried. I don't know any of those conversations, but I know that when we would talk, he would like to have it, or he would have liked to have it done. It seemed like a dead end for him every step of the way, and I wish I knew why it never got there.
And so when you entered the company, how far along was the Titan project?
So Dave Dyer at APL had a mechanical systems drawing. Pete Brodsky had the control system done. That was all done on Cyclops 1. The landing gear, everything external to the hull, that was on Cyclops 1. Mechanical and electrical was already done, by APL. There was a company in, I think it was Albany, Oregon, that was to cast the titanium domes. Turned out to be not a viable option. Brian Spencer of Spencer Composites had the hull figured out. His analyst, Grover, produced a design and analysis report that said that this thing is going to go well beyond, which I can show you later, well beyond what the target was. All those parts were in place. That's it. We were supposed to get the same parts that were on Cyclops 1 and put them on Cyclops 2, and great, put it together. Let's go test it, qual it, cert it, and done.
So what was your role as a director of engineering specific to the Titan project when you came in with Titan?
It was to bring that together. Right.
And what were some of the challenges that you faced with implementing Cyclops 1 parts, specifications, applications, and accessories to the carbon fiber hull on the Titan?
That's a good question. So the big challenge with for the differences between Cyclops 1 and Titan, and I gotta say, when we're talking about Titan here, and me with respect to Titan, and we're talking about the development, this is serial number 1. Like what they did in serial number 2, I don't know. So
You can expound on that.
yeah, so and it's kind of, I don't want to make a ton of corrections to your presentation. Loved it. It was great. I think on sheet 2, it talked about Titan. There was no differentiating Titan, but there absolutely is. That serial number 1 is not serial number 2. And then I wish I think it was sheet 1, we're talking about, I think it's the very first sentence in the very first paragraph, we talked about identifying whether or not there's technical issues and design problems and whatnot, but culture is missing from there. I wish I would have seen culture on there, for sure. But the differences between Cyclops 1 and Titan serial number 1. Where are you going to get the power from? So Cyclops 1 had the power for the thrusters and everything internal, underneath the floor, big battery bank. We couldn't do that in Titan. And Cyclops 2, that was a huge difference. Yeah. Another significant difference was Omar at Interspace kept promising the thrusters to us, and this went on for months. I would call him, it seemed like every week, and he finally said, well, I can't give you the same ones. You're going to have a different thruster, and I think it had to do something with the resolver inside the thruster, but it was a way that the thruster communicated with whatever inputs were coming in. That's where I wanted to stop my education on thrusters. That's it. But okay, so I can't use that, and that forced me to hire an electrical engineer and a software engineer, because everything that Pete Brodsky had done at APL was now not going to be used. And then now all the hardware that was inside the control bottles had to be changed and different. And so the systems-wise, the most difficult part of that transition really was the control system and how are we going to store battery power? How are we going to get that? between the two submersibles.
And I think it's important with your role as the Director of Engineering with regards to Cyclops 1 into the Titan project to understand the timeline of the University of Washington Applied Physics Lab, which you had mentioned earlier. What was the role of the University of Washington Applied Physics Lab as you knew it as a Director of Engineering?
Dave Dyer was the mechanical representative, so he was a mechanical engineer. He did mechanical systems, so bladders, designs, landing gear, stuff like that. If it had a wire going to it, Dave wasn't your person. Pete Brodsky did controls, and then the operations group really did the primary power, secondary power, battery, storage. But for APL, that was it.
And how would you describe the working relationship between the University of Washington Applied Physics Lab and OceanGate?
It depends on who you were.
In your
If
perspective?
you were, from my perspective,
Yeah.
Pete Brodsky and I got along well. Pete Brodsky in Stockton, not so much as we got to Titan. Titan. Pete wasn't okay with using glass spheres on the outside and decided to remove himself from the project for that reason. And respectfully, Stockton didn't make a big issue of it to Pete at all, but he was mattered and all get out for sure. He was not happy about that because we were losing Pete. And Dave Dyer, if you were the director of operations at the time was Scott Griffith, and then marine operations was Dave Lockridge. That working relationship was great, but it wasn't so great with me.
And this is approximately 2016 to 2017?
This is 2016. This is spring of 2016, early summer, late spring. As we got into the June, I think it was June or July, we tested the 1/3 scale to find out where it destructed. So that was that summer. So leading into that, very tumultuous time. So starting about a week or two after I hired on, up until that implosion.
And that was with you in the operations division or with UW APL?
No, the UW APL, the Dave Dyer with very cozy to Scott Griffith and David Lockridge. It was in May of that time when I put together a good case to sever that relationship, and we did.
And that's about the time that you decided, or OceanGate decided to bring all engineering in-house with the exception of utilizing the testing facility at UW APL?
We did, yeah. We had to.
And you had mentioned the glass spheres, the motor pod controllers that are external to the pressure hull.
Mm-hmm.
Can you describe to me what those are and why they're utilized and why glass was so important?
The glass spheres, they're actually rated really, really well. You can go deep with those things, and they're used in other systems. So this is, in engineering, we would call it COTS. It's commercial off the shelf. And don't reinvent something if somebody's already got it. And the glass spheres, or it comes with some baggage. Got to take care of them. And you have to really be careful about the sealing surfaces, and when maintenance on them is a little bit trickier because when you take the two halves apart, you now have glass spheres to worry about. But if you oil fill them, your depth is. We'd have to look at the spec sheet. Let's say it's really deep because of oil being non-compressible. So glass spheres was always seen as a great option for the durability and the ability to go. The issue with glass spheres is if they're not oil filled and they fail, it's catastrophic. It's an implosion, and it's not like a metal or a metallic implosion. These have very, very high strength values, but they're brittle, just like the glass in our homes.
And so the University of Washington Applied Physics Lab said that utilizing glass spheres in the atmosphere on the outside, so not in the pressure hull, was a no starter for them.
For Pete Brodsky, for sure. And you wouldn't put glass spheres in the inside. Well, I guess you could. It'd be overkill. But for the outside, no. And even oil filling them, Pete was not. He was not okay with it. And so personally, he didn't want to be part of it.
And that was the point at which OceanGate ceased the engineering
With Pete.
with Pete.
Yep.
Did it continue with Mr. Dyer?
If I remember right, we severed Mr. Dyer with Dave Dyer before Pete. I think we tried to get Pete's help after. I'd have to take a look at that timeline again, but I'm trying to. Dave Dyer was the more pressing issue because that was the early summer of 2016, where engineering actions that we had to do to complete the bill. He was just non-communicating, and that's really the time. But Pete was after that. And so, actually, it's fair to say that we didn't sever the relationship with APL all at once at the same time. This is a phased-out approach.
And did you end up utilizing the glass spheres as the motor pod controller?
I think we ended up, if I remember right, we designed some aluminum spheres, tested them. I don't think they survived very well, so we went to glass, oil filled them, if I remember right. I'd have to shake that one out of the brain.
You mentioned Spencer Composites. Were you involved in the carbon fiber hull winding process?
I watched the whole thing. That's it. So in the process itself, you're talking about the physical
Correct.
build of it.
Yes.
Yeah, so I set up GoPro cameras and watched most of it. I think it took a month, so 4 or 6 weeks or something like that. It was a long time. But I went and watched it. We were watching for. We were just watching for bad behavior. Is it more than anything? Not that we didn't trust them. Just carbon fiber structures are really all about process, and you want to make sure that the process is done well. So we wanted to watch that.
Did you ever visit Spencer Composites, and what was your technical opinion of the facilities and processes which you
Oh, a lot, yeah. Well, technical opinion, Brian's done a lot of neat stuff. He's built a lot of, and he prides himself on doing the one-offs, for sure. Facility-wise, it's a bit dirty for me. I guess it wasn't for him, but it was a little bit of a concern of ours. Thought, well, let's just make sure that nobody's, blowing the leaf blower around here because of all this dust while they're winding it. It definitely wasn't aviation grade, clean facility, for sure.
And can you describe the process and why contamination in the area would be extremely important to the hull?
Well, so I have to say that's not my expertise.
Okay.
That's Brian's. And I mentioned to Brian, do we put a hood over this? No, it's fine. I thought, oh, okay. So part of the GoPro cameras and me watching it was we didn't want to make sure no bird flying ahead laid anything to rest inside the windings while it was going down. So it was a little bit of a babysitting job, because if it was a suggestion that we made, such as we're going to put a hood over this, are we worried about dust or something, it was definitely not well received.
And as the director of engineering, did you make all engineering decisions?
No.
Did you make any engineering decisions?
Yes.
And who would make the majority of the engineering decisions?
It was Stockton, for sure. And so I just want to mention that I can't remember the name of this poem. I think it's a poem, right? But grant me the serenity to accept the things I cannot change, the courage to change the things that I can, and the wisdom to know the difference. My job as the director of engineering is more about rounding up the cattle than it is about making all the choices, for sure. Showing the leadership to the younger people that are coming in, but then maybe to raise the technical questions when it's appropriate and go do that research. If I could control it, or if I did control it, it was a significant problem or a significant issue, which maybe we'll talk about. That's how 18 strain gauges got on the hull. I wasn't going to settle for anything else. So an engineering decision like that, I made it. And Stockton and I argued about it a lot. But pretty much, if the technical decision for, well, let's say the technical decisions for the case itself, the carbon fiber structure, as Brian Spencer, I could raise the alarms all I want, but it's Brian Spencer, and I look at Stockton, and he'd say, this is what we got. This is what we're going with. To the extent that I wasn't comfortable really with the fact that we weren't going to have witness panels. I couldn't understand that about Brian. Like, how would you build this without a witness panel? That's so basic. Seems so basic. But I couldn't stop that. To get the witness panels, the manual was already done, and Stockton wanted to go with that. So this is just a couple of examples of how I could influence it in some things that, if it mattered enough, then I'd fight for it. And if it didn't matter enough, I'd find a way I can mitigate it.
And was that Mr. Rush's management technique just to you, or was that employed throughout others that you witnessed at OceanGate?
Yeah, Stockton, I'm struggling to find the professional words to be able to put it. I'm an old Navy diver, right? There's a bunch of words I could use, but Stockton would fight for what he wanted, and what he wanted, even if it changed from day to day, right? Like he would fight for what he wanted, and he wouldn't give an inch much at all. So the fights that I had with Stockton, most of it behind closed doors, because as the director of engineering, let's keep continuity in the crew, and they can't really know that the two people on top are in solid disagreement. Most people would just eventually back down from Stockton. Like it was almost death by 1,000 cuts in most of the things. I hope that answers that question. I don't know a really good professional way to organize that in my brain right now.
Understood. You had mentioned witness panels. Can you briefly explain what a witness panel is for the record?
Right. So witness panel. If you were to, what was the whole, like 8 feet or something? If you're going to make an 8-foot carbon fiber structure like this, make 2 extra feet. Cut those off. Keep those in a vault or someplace temperature controlled, humidity controlled, and wrap them up. So if you have a problem, you can go back to what it was. You can do mechanical testing on it. You can do chemical testing on it. You can send it to where you need to go. But if, like in the case where we're sitting here today, somebody's going to try to come up with a reason why this thing imploded, serial number 2 now, without a way to know how it was built. In these types of systems, that's a pretty important thing to do.
Did you make that recommendation?
100%. 100%.
And it was denied by,
Brian Spencer in Stockton. The mandrel was already built and the size was already committed. So when I came into the program, that was done. They already had a plan to go forward with it. So there's, some, I think it was David Lockridge's complaint. I think in one of the complaints was you can see light through the end. Well, that's because there's the 3 inches. If you could see light, I mean, there's discussion to happen around that, but let's suppose that you could. That's the 3 inches that was supposed to be cut off. Witness panel would have been the one to measure that, and Brian Stockton didn't want to do it. Stockton, I think for that one, Stockton was more open to it. I think he was already it was already on course to get done, right? I came into the program for serial number 1, and they had already, the size was committed, mandrel was already committed and built. Brian Spencer already had his path. Items like that, and the fact that maybe we shouldn't cast titanium domes and put this in deep sea pressure because of the void concentration, Stockton really didn't know and understand at the time. And for a while there was probably a honeymoon phase with Stockton and I for a while, because it kind of blew his mind. He actually told me one day over lunch, he's like, "Thank God you were here."
and why do you think he was making those decisions? Are you aware of why he was making those decisions? Was there a benefit to him, or just the way he thought?
To not like build another mandrel?
Correct.
Oh, it was cost. Yeah. I mean, we could have done it.
And what about testing? Was any testing conducted on the first Titan hull? Prior or while it was just after its manufacturing?
Right. Okay. So, yeah. So mechanical testing really wasn't something that we could do on it. Acoustic testing, we wanted to do on it, and we tried. We had some experts come and take a look at the parts that were cut off and try to get through the hull. We went and saw Boeing acoustic experts and said, how can we go do this and go find whether or not we have voids in there? And Stockton and I were concerned about a void in an interstitial void, or which could either be a delam, a full delamination, or not. So when I say a void, there's going to be microvoids in there. Let me back up and say, when I'm talking void at this scale, it's a large scale void. It's a intralayer delamination. So we were concerned about that because of what we saw in the 1/3 scale, and so we reached out to Boeing and went down there and talked to them, like, how can we get a good measurement? At 5 inches thick, you really start to lose your ability to do that well. Two types of acoustic emissions, which maybe we'll talk about later, right? We had some experts look at it, and we didn't yield results that we could do much with.
You've talked about 1/3 scale models.
Mm-hmm.
Can you explain to me the importance of a 1/3 scale model and walk me through the 1/3 scale model testing that was conducted when you were the director of engineering?
Sure, right. So I came in March of 2016. They already had a 1/3 scale model built.
Who built all the 1/3 scale?
Brian Spencer. Yeah. So serial number 1 is that hull. It's all Brian. It's there isn't any carbon fiber or anything that was not Brian for serial number 1, and that's my tenure, all the way to June 2019. So the 1/3 scale, the importance of the 1/3 scale is structures like this can be very linear. If they're nonlinear, that's a much different problem. And so if you're 1/3 scale and you go to 1/3 to depth, and you have 1/3 nearly everything and it's linear in its path, then you can scale up. And you can scale up by just drawing a straight line. Engineers like that stuff. It's when we start doing this things get complicated. So the 1/3 scale was seen as a way to understand whether or not the full scale would operate and how good it would be, assuming the elephant in the room is that you make the 1/3 scale the same way that you make the full. And carbon fiber structures are all about processing. And so if you have two people that are making a 1/3 scale and you wind that, it might take you a week or so. But when you do 6 weeks of winding a very, very large, that process should be controlled probably pretty well. You want to make sure you get that same result.
And was it in this case?
For our 1/3, so that particular 1/3 scale, so it suffered, before I got there, I actually got to see the carbon fiber dome implosion in March of 2016. That was before I actually came on. Stockton invited me to, hey, come watch this. I thought, great. Went down to UW and saw this, and that was a rapid decompression. I don't know much about it, except that apparently there was 2 others before. They've tested this thing. Nice slide. Look at the States. I learned a lot. 2 other decompressions, and so the 4th test, when we tested that 3rd scale in June of 2016, wasn't surprised that it failed where it did, but also not surprised because I just so happened to have a piece of virgin material that I could take to Boeing, and we scanned it, and we believe we saw a DLAM about a quarter inch in, and so that was predicted to implode before, like where Brian thought that it would go, and what his design and analysis report would tell us.
And if these 1/3 scale models were imploding, was anything changed to the manufacturing process of the full hull to actually meet the requirements of the build?
For serial number 1, Brian was not willing to change anything that he did.
So the 1/3 scale models, which were tested, did not meet the requirements of what would be a full scale to get to the depth of 4,000 meters.
Yeah, I don't remember my conversation with Brian. I said it kind of fell short of what your DAR, a design and analysis report, is saying that we should be. Stockton's justification was, well, it's suffered 3 other rapid decompressions, and it's a compromised hull. You'd have to do one that's brand new. And Brian Spencer wasn't willing to do anything different. He held firm that his hull was going to hold. So when we went to titanium, I put together, there's actually a plan and drawings for this, to do a 1/3 scale with 1/3 titanium domes and 1/3 viewport. I think that cost came in at, it was going to be like 100,000, 150,000, something like that total, and that was killed. So we weren't going to be able to do that. But another 1/3 scale for the engineering department was planned.
And with the 1/3 scale testing, were you actually able to ever to get to the pressure which would equivalent to the depth that you were rated for?
So I think the target requirement, if I remember, it was 4,000 meters, right? And we imploded the 1/3 scale at 42, I believe, but we wanted, the conservatism that Stockton wanted was 45. So we met the target depth, the target operational depth, with conservatism, if Titanic was the target goal, not to put 3,300 meters on there, we made it 4,000, and then 4,000, another 500 on top of that, feeling like that was going to be the conservatism. Stockton was okay with that, and so we never met the 4,500, if I remember right. Like, I don't even know if I have that sheet. You guys might know. We can talk about that.
So that 1/3 scale model that you said, or sort of stated, that made it to a 4,200.
I think we imploded at 42, if I remember right. It could be wrong, but this is definitely discoverable.
In your opinion, was that the exact 1/3 scale model of what the full hull was for the first time?
It was, yeah. Surprisingly, he made it 1/3. Yeah.
Moving forward from the 1/3 scale models, I'd like to talk a little bit about the gluing procedures.
Sure.
The titanium end gluing procedures.
Right.
Can you talk a little bit more about that?
Yeah. What do you want to know?
So one,
There's a lot to it.
there is a lot to it. If you could talk a little bit about the procedure that you used, the glue that you used, and if you had any, professional consultation on how this was done.
Right, so the professional consultation was, Brian, I'm going to move this over here. The professional consultation was Brian Spencer. That's gluing carbon fiber structures is additionally his expertise. That's what he does. Brian sent the two people that wound the serial number 1 to Alameda, where we had very big lathes and cranes, and so we had to prep the gluing interface and have a way to move it around and put the titanium rings on it and get the alignment right. So I wasn't comfortable with doing that myself. So we got Brian Spencer to send 2 staff to go do the gluing procedure. And what I made sure was that we were on square, straight. And so when that was done, it was plumb and level. And that's what I cared about most. How to glue that is Brian's expertise. And I think you asked what material we used. On serial number 1, I think we used EA 9394, if I remember right, with a compressibility of like 56,000 KSI. Which really, really strong stuff, and we might get into a discussion later on that interface. I mean, all material science and all engineering is all at the interfaces, and so that's an important thing to know.
And had this been used before in deep sea submersible industry?
I don't know. It's a good question. Brian wasn't willing. I wanted something a little bit more flexible, and he wasn't willing to change that.
So you had mentioned Boeing.
Mm-hmm.
What involvement did Boeing have in the first Titan hull?
Okay, so it's a good question. Important to break up OceanGate into 3 companies or 3 phases, really. There's OceanGate 0.0. That's pre-March of 2016. Then there's OceanGate 1.0. That's serial number 1, March of 2016 to June of 2019. That's my tenure. Then there's OceanGate 2.0, and that's Dan Scoville and Phil Brooks, June of 2019 on. Boeing was mostly involved with 0.0. And I don't know a lot about that. Mark Nagley, I think, is on your list to talk to. Mark did some analysis, I believe, for Stockton. I did go to Boeing to take parts to them to get acoustic data on, so some of the testing for the 1/3 scale. And I took the pieces of the cutoff pieces, if I could learn anything from the full hull. And we met with some acoustic folks in Boeing, trying to understand, like, how could we how can we go measure and verify void concentration in this? And from my tenure, that's about where it goes, and that's it.
Did yourself or OceanGate ever make notice of the Titan or notify make notice of the Titan and its construction and purpose to the Coast Guard?
Did we make notification to the Coast Guard that we were building it?
Yes.
Is that? Oh, I don't know. Yeah, business choice. I was strictly technical, and Stockton liked to keep him and Neil. They kept the business to them. So quite honestly, I had my hands full, and I wouldn't want to know it.
Okay. So if you were strictly technical, would you have been aware if classification societies were ever notified or discussed with for the Titan submersible?
So I know Stockton was in a spat with folks from the class societies. I don't know them all. He would bring me in if he would talk about, he was annoyed. Another role, a director of engineering, you're the shoulder everybody cries on. And, I'd listen to him. And he was annoyed that they wrote letters to him, and it was too expensive to class, and they didn't want to be part of the project. Yeah, that's what I know about that. I wish, quite honestly, I wish they would have been part of the project. I mean, to do a collaborative venture on this would have been nice. On a professional scale, it was annoying to me that we didn't share data, or they didn't want to be part of it.
At what point did you know that the submersible is not going to be classed or adhere to structural standards of the class society?
Right, that's a good question. I don't know when we took this divergence. So the divergences were, I don't remember there being a defined day that, hey, we're going to try to get it classed here, and then we're going to go off this way. It was starting in the summer of 2006. Probably the summer of 2016. It was probably about the time we had to make the decision to go from grade 5 to grade 3 titanium, which I know I totally forgot that we did when I first talked to you guys. It was about that time where we were ramping up so much that there was almost felt like there was no room for it. I wish I had a better answer than that, but there was no discussion ever of now getting classed, and it was a further divergence from their involvement.
And with regard to the classification society, so discussing the classification society and the carbon fiber structure, was that the major issue with not being able to go classed?
I think it was part of the issue. Stockton's first issue was time and cost, like to go through their plan, and I think he really wanted them to be part of it. But I think the plan that they came up with, if I remember right, one of the days he was crying on my shoulder. It's going to take too long and way too expensive. He said, it's ridiculous. And in his words, it stifles innovation. I said, well, you could still be innovative. It might take a little bit longer, but there was a divorcing, so to speak, over the idea when he couldn't get traction on what he wanted.
Was there any discussion regarding classification societies and the structural safety of the hull?
What do you mean?
So the classification society provides, as you stated earlier, will provide oversight, consistent testing, retesting, which would in my, or in anybody's eyes, you're looking at extended safety, right? So if it's not being classed because it takes too much time, it's too expensive. So in your mind, are you saying that you're giving up a little bit on safety to take away from the cost?
Classing, I don't think classing would have prevented this accident. And certification, my comment earlier holds, right? I mean, aircraft are certificated, and we still lose them. So that by itself, just by itself, I want to be careful in how I answer this, right? Because that is not going to prevent 100%. We absolutely could. We could 100%, engineering-wise, prevent all traffic accident deaths. 100%. We would all be giving up a lot of convenience to do that. Right? So the idea that we go through this certification or and this classification, it gives us a path to get there with good confidence that we're going to be successful, but certainly it doesn't prevent things like that. But that's with let's say classing of vessels and whatnot. There's other guidance that we look at, like ASME, right, that you want to follow, and engineers should follow. And I have some stuff that we could talk about. And so we didn't, for serial number one, we if we get to this here, which I hope we do, in the technical notes, that we followed the guidance that engineers would follow for solid development. And in fact, the analyst that I hired was a Boeing. I chose an aviation analyst to do the FAA models for that reason, so that we could follow like ASME guidance and put more of an aviation type discipline and standard into the development of what we're going to go build.
At the time of the build for the first Titan hull, was carbon fiber an approved material to be used from a classification society?
No, they didn't. I don't think so. I don't think they had a path for it, okay. Which was a little bit of probably the issue for Stockton.
Was the hull certified and stamped by a professional engineer?
I don't know if Brian Spencer is a professional engineer. He's the it's a good question. I don't know, like that cool.
Did you or OceanGate register the hull with the Washington State Pressure Vessel Commission?
I wouldn't know if whether the business did that.
In your initial interview, Mr. Nissen, you mentioned that you were certified in conformity assessment tests and have worked extensively with regulatory agencies, including indicating a broad understanding of compliance requirements. Given your background, why was there no effort or attempt to ensure compliance with the classification standards or regulatory compliance during your tenure as a director of engineering?
I wouldn't say that there was no effort. There was no desire by Stockton to go do it. Right. All my conversations with Stockton were not about avoiding class. Not at all.
With regards to the Titan timeline around December of 2017, as the Titan is being completed, can you describe to me the Titan vehicle and its layout as it then went into the manned testing?
Okay, wait. Say that again. So the layout.
So in December of 2017, the original Titan hull is now complete.
Yep.
December to January of 2017.
Okay. December,
Can you describe to me the Titan vehicle and its layout? So we had discussed. Go ahead.
Right, carbon fiber structure, 2 titanium domes on the end, acrylic viewport in the front, a shell on the outside, a fiberglass shell to protect anything from the inside. I think there was ballast bladders. Drop weight mechanism that looked like we modeled that after like a gun turret or a gun magazine for drop weight underneath. And batteries for control systems. Thruster batteries were on the outside, control system was on the outside, house power was on the inside. Computer systems modeled aviation, where we had a critical bus, essential bus, and a non-essential bus, depending on what you wanted to have in reserve. The engineering department was not responsible for and was not allowed to do any of the life support systems inside, so oxygen tubing and oxygen systems that would come from operations. And so engineering-wise, that pretty close to mounting all the cameras and stuff that was underneath.
You had mentioned David Lockridge
Mhm.
previous.
Yeah.
Were you involved in creating his inspection report?
No, I didn't know that he was doing it. So we asked David to do, we needed, so when serial number 1 was complete, we needed a handoff to operations. Like, you know, and that's a very standard thing to do in large companies. Eventually, the technical department has to not handle this anymore. And so we told David, I said, hey, from an operations perspective, like, tell us, what are we missing? Like, what do you need? David was the perfect subpilot for this. He was great. I really wish the news would get his relationship with engineering correct. We depended on him to know that things were right from an operational point of view. And that's the report that we wanted to know. Like, is there something that we could go help with to do? The report that he came back with, I was surprised by. I'm not shocked in the sense that I understand why he wrote it, and I understand the difficulties that he had in communicating his wishes through Stockton, and yeah, I understand why.
Were you at the meeting where he himself and Mr. Stockton had discussed the findings?
I was, and we could probably call it, in air quotes, the meeting, and it's the one where eventually he was let go, right?
Had you talked to Mr. Rush prior to the meeting
About
the inspection report and the future of Mr. Lockridge?
I can't remember. I would think so. I don't know how I would show up at the meeting, to tell you the truth, if I hadn't seen it, or maybe I was surprised, and quite honestly, maybe I saw it first and I sent it to Stockton, like, hey, you've seen that? Maybe that's a long way to say I don't know. I can't remember if we discussed it before.
Do you know if the board of directors was informed of Mr. Lockridge's inspection findings?
No, no, and that's really both a personal and professional point of contention with me. I mean, I stopped the 2019 Titanic dive because the data, the instrumentation that I put on it wasn't good, and I was fired for it. And what I got from Stockton is the board said that you should have known this was happening. And I said, well, let me point you to exhibits A, B, C, and D that I've been telling you. Like, why aren't we telling the board? So I don't know that, I don't think Stockton communicated to the board with those things, but I mean, if I'm not sitting in the meeting, I wouldn't know.
Okay. So in the spring of 2018, the Titan was then shipped or taken to the Bahamas to conduct testing.
Yep.
Were you there for any of the testing initially?
Can I answer this with both yes and unfortunately? I was there.
Care to expound?
So once the engineering team turns something over, right, you're done. We've shown that it works. The systems work. You communicate how to take care of it, and then you field the issues that come in. And in my roles in the past, we would call these things MRB, material review boards, right? So you'd have a nonconformance or something where an engineer has to go answer it. We'd have to provide the disposition for it. And that's the phase that we should have gone to. And quite honestly, I didn't have a desire to go step foot in the Bahamas. I didn't want to be, the operations group was not a fun place for me to work, and I didn't want to be there.
But there was a planned expedition in June to July of 2018, is that correct?
Oh, there was, yeah, right. So I wrote the I wrote the qual plan for it. The first time we put it in the water, I dropped it on a fishing line, 200-pound strength deep sea fishing line, because I could calculate the buoyancy. I was 150 pounds negative, and we started with that. And I wrote a series of plans for them to go do this, and I wanted to see the data to buy off on the idea and whether or not we were seeing what we expected to see.
How did you confirm the depth at which the hull would have reached?
We had an acoustic transmission on board, so same thing that we saw here that communicates to the top, and there's a way to ping items underwater and sends you a return on the depth, whatever it is, and so we had these systems on there.
And what was the testing plan in 2018?
You want specifically, or kind of like a broad?
Specific, if you
Yeah,
don't mind.
right.
I can also so was there a plan to go to the deep ocean test facility prior to 2018?
Oh, there was.
There was, or there was not?
Oh no, there was. Yeah, that was part of like my interview was that this is where we're going to go test it. I thought, great.
Did that ever happen?
No.
And why not?
One reason was the deep ocean test facility. In order to we wanted to hydrostatically test, so we wanted to fill it with fluid, but there was going to be computers inside because we had to measure data and needed to isolate that from the water. And the deep ocean test facility wasn't comfortable with us doing that. I submitted a plan, a request to be able to do this. They came back with, we don't know if we want to do that. This is one of those cases where Stockton got fed up and said, then we're not going. And it was going to push us like another year. Like I couldn't get it done fast enough at all. So they said we won't go.
And so when the Titan was in the Bahamas in 2018, was there, what happened to the hull?
Well, okay, let me, if I could, let me back up. So your last question, in 2018, right, the plans, what we then moved to, we used, there's a guy by the name of Alan Green, who's an acoustic expert, that came to us and we showed him what we were going to do. He said, you're more than, I have his report with me too, we could take a look at it if you like. There's more than enough, your system's adequate, more than adequate to be able to detect what you're doing. And he gave us some suggestions on cycling and how to do this test. And so all those were scheduled to be executed live in the Bahamas, which is what we wanted to do. During testing, or when it was there in April of, what's that going to be, 2018?
2018.
It got hit by lightning. I know your presentation says alleged. That is a difficult thing to prove, except I had to drag a lot of my engineering team down there to replace all the electronics in it, and I could find all the lightning traces. So it took high energy for sure. And interestingly, down there, there was a catamaran, brand new catamaran that was behind us. And you know the tech rep that was there, you know them by their tech shirts, and I'm a rep, and I asked them, hey, what are you doing? And they said, replacing all the electronics. And I thought, no, why are you doing that? And he said, because it just got hit by lightning. And then he showed me a picture of, on a catamaran, right, this twin screwed starboard side, just blew a hole right out the back of the propeller. That catamaran was sitting right next to Titan at the time. So the hull, what happened to the hull down there, so back to your question, is I believe it got compromised by that event. That's very difficult to detect, that I could see later on the data. But it went through, I mean, it took a lightning strike and it went through all the testing.
So at that point, did you cancel the 2018 Titanic expedition?
It had to, yeah, because we gutted it, changed all the electronics in it. We weren't going to be able to do the deep diving that we needed in time. There's no path to get there. It would have had to leave. I think it had to leave the Bahamas to go to Newfoundland sometime in May, I think it was. Yeah, and then they couldn't get there.
At that time, did you believe that the lightning strike affected the actual carbon fiber hull?
Yeah, I told Stockton and said that there's probably a good chance that hull's compromised. For sure.
And what did he say?
It'll be okay.
So nothing was done to the hull itself from that point on? You didn't make a new hull? It wasn't created?
No, so the strain data that we got back, the strain in the acoustic, so I mean, I wrote a couple of reports that, I don't know if you guys have them or you want to look at them. Give me just a sec, because this is, so I wrote this to Brian Spencer, where I told him that the,
Mr. Nissen, what is it that you're reading there?
so this is my quick dive. So I wrote a qual dive quick look for Brian in August of 2018, and it's because I got a good look at the 4 kilometer data, and so I told Brian and
Mr.
Stockton.
Nissen, Mr. Nissen, hold on just 1 second.
Yeah.
Mr. Nissen, did you provide this document previously, or is this a new report
Previously to where?
to the board?
No, this is no
Okay.
report.
I think we've been going for about an hour. Why don't we take about a 10-minute recess?
Sure.
And let us, look at this document before you reference it, and that would give everyone a chance to.
Oh, yeah,
get
right
familiar
on.
with
Sure,
it. Great.
sure.
So at this time, the board will recess and reconvene at 11:15. Thank you.